12th MCQ. Statement A, it's about BCl3, AlCl3 and GaCl3. When we consider these chlorides, the central atom of BCl3 is boron. What is the valence shell of boron atom? It is second principal energy level. Then what about aluminium? The valence shell is third principal energy level. Gallium, valence shell is fourth principal energy level. So when we consider MCl bond, it's clear that MCl bond should increase in the order of BCl3, AlCl3, GaCl3 as the size of the sp2 hybrid orbital increases in the order of BCl3, AlCl3, GaCl3. What is the reason for that? The valence shell is second principal energy level, third principal energy level, fourth principal energy level. In that order, the size of s orbitals and size of p orbitals increases. So when we consider BCl3, AlCl3 and GaCl3, the central atom is in sp2 hybridization because there are 3 sigma bonds and the shape of each of these molecules are trigonal planar. So when the size of s orbital and size of p orbitals increases, the sp2 hybrid size of sp2 hybrid orbital increases. Therefore, it is clear that BCl, AlCl, GaCl in that order, MCl bond length increases. So let's check the statement A. Ascending order of MCl bond length is BCl3, AlCl3, GaCl3. So it's clear that statement A is correct. Now let's move to statement B. Ascending order of thermal stability of magnesium carbonate, calcium carbonate and barium carbonate is in that order. Let's take the formula of carbonates as MCO3, general formula. So there is M ion and the carbonate ion. We can draw the Lewis structure of carbonate ion. There are 2 negative charges. We can mark those 2 negative charges on oxygen atom because when we consider carbon and oxygen, the most electronegative element is oxygen. Therefore, we can mark the negative charge on oxygen atom. So what happens? This M cation attracts electrons from this oxygen atom. We can mark that attraction like this. When electrons are attracted from the cation, what happens? The carbon-oxygen bond dissociates, taking bond electrons by the oxygen atom. So this results an oxide ion. Due to this bond dissociation, oxygen atom gains an extra electron, the electron of carbon atom. Therefore, there will be a negative charge. Already it is negative. Therefore, finally, an oxide ion is formed. When these 2 bonded together, it is the oxide of the metal. Then what happens to this part? Due to this bond dissociation, the charge of carbon atom becomes positive because the valence electrons of carbon atom is gained by oxygen atom. Then this is negatively charged. That means there is an extra electron. So that extra electron can be transferred to this carbon atom. Then this is neutral, this is neutral. Both atoms have unpaired electrons. Therefore, a covalent bond can be formed. There is a covalent bond. So what's this? It is carbon dioxide. So we can explain the thermal decomposition of this carbonate like this. So what are the cations? Magnesium, calcium and barium. Magnesium cation, calcium cation, barium cation. So in this order, the size of the cation increases. What happens when the size of the cation increases? Polarizing power decreases. Therefore, in that order, polarizing power decreases. When polarizing power decreases, ability to attract electron from this oxygen atom. Polarizing power means the ability to attract electron from the negative ion. So the ability to attract electron from this oxygen atom and dissociate this bond to make the oxide reduces. So it is clear that magnesium carbonate, calcium carbonate, barium carbonate, in that order, ability to form oxide and carbon dioxide decreases. So if that ability decreases, we need to supply external energy to decompose the given carbonate to oxide and carbon dioxide. So ability to form the oxide and carbon dioxide decreases. That means the stability of the carbonate increases. It doesn't tend to form oxide and carbon dioxide. That means stability increases. Therefore, it's clear that in this order, thermal stability of carbonates increases. As the stability has increased, we need to supply more energy to decompose carbonates in the order of magnesium carbonate, calcium carbonate and barium carbonate. So it's clear that the statement B is also correct. Statement B is ascending order of thermal stability is magnesium carbonate, calcium carbonate and barium carbonate. That is the correct order. Therefore, it is correct. Statement C is about bond angles. H2O, H2S, H2SC. So we know that valence shell of oxygen is second principal energy level, where valence shell of sulfur is third principal energy level. Valence shell of selenium is fourth principal energy level. The shape of all these molecules are angular and hybridization is sp3. So 2s, 2p hybridized to form sp3 hybrid orbitals. 3s, 3p are hybridized to form sp3 hybrid orbitals. 4s, 4p orbitals are hybridized to form sp3 hybrid orbitals. So size of sp3 hybrid orbital increases in the order of oxygen, sulfur and selenium. Size increases in that order. Therefore, we can draw the given molecules like this. When the size of sp3 hybrid orbitals increases with paired electrons, the repulsion from orbitals with paired electrons to bonding electron pairs increases. So in that order, repulsion increases. Therefore, these angles, the size of these angles increases. Because of that, the bond angle reduces. When angles between paired electrons and bonding electrons increases, what happens? The angle between bonding electron pairs decreases. Therefore, bond angle in water molecule is greater than bond angle in H2S molecule. Bond angle in H2SC is the lowest among these three molecules. So that's how we explain the variation of bond angle in H2O, H2S and H2SC. Let's check the given statement. The bond angle decreases as H2SC, H2S, H2O. That is incorrect. Bond angle increases in that order. Bond angle in water molecule is about 104 degrees. Then bond angle in hydrogen sulfide is about 92 degrees. Bond angle of H2SC molecule is about 91 degrees. So it's clear that our logic is correct according to the observations. Then we can move to the statement D. It's about TiCl4, TiCl3, TiCl2. So what is the oxidation number of titanium atom? +4, +3, +2. So when the oxidation number decreases, the ability to attract bonding electrons decreases. Therefore, electronegativity decreases. in the order of TiCl4, TiCl3, TiCl2. So what about the statement? Electronegativity increases as TiCl4, TiCl3, TiCl2. That statement is incorrect. Statement A, statement B, they are correct. Therefore, correct answer for this question is first one. According to the instructions given in the question paper, when statement A and statement B are correct, the correct answer or correct response for that question is first one. So that's how you should get the answer for this question. So there are many things to remember to write the answer for this question. If you want to boost your chemistry marks, you can join our online paper discussion class. WhatsApp now to join. Don't wait. To get this question paper free of charge, WhatsApp now to 071 7191 626.